Hello, in this session we'll see another question on lines of regression. So the question is as such, for 5 pairs of observations we have summation of x is equal to 15, summation of y equal to 25, summation of x square equal to 55, summation of y square equal to 135, and summation of xy equal to 83. So basically we have to find the equation of lines of regression and also estimate x when y is equal to 12 and y when x will be equal to 8. So clearly we can see that we have to find x as the dependent variable when y that is equal to 12 is the independent variable, and find y that is the dependent variable when x equal to 8 is the independent variable. So with all the informations provided here, we'll try to find the regression coefficient and then the regression line. So starting with the solution, the first observation is 5 pairs of observation. So this gives n equal to 5. And with other informations already given here, we will use that to find the values of the mean and the regression coefficient and finally the regression line. So starting with finding the mean value, this will be summation of x by n. This will become 15 over 5 equal to 3, and mean y, that will be summation of y over n, which will become 25 over 5 equal to 5. Now finding the regression coefficient of x on y. So this will be given as bxy equal to n times of summation of the product xy minus product of the summation x and product of n times of summation of product xy minus product of summation x and summation y divided by n times of summation of y square minus square of summation y. So as we have all the details already provided here, this will become 5 times of 83 minus 15 times of 25 divided by 5 times of 135 minus 25 square, and this becomes bxy equal to 0.8. So this is the regression coefficient of x on y, and with this the regression equation of x on y, which will be given as x minus x mean equal to bxy times of y minus y mean, will become x minus 3 equal to 0.8 times of y minus 5, and this gives x minus 3 equal to 0.8 times of y minus 4, and therefore x becomes 0.8 y minus 4 plus 3, and this is x equal to 0.8 y minus 1. So this is the regression equation of x on y. So this is the first line, that is x on y. Similarly, we'll find the regression coefficient of y on x, and this will be given as byx equal to n times of summation of xy minus product of summation x and summation y divided by n times of summation x square minus square of the summation x. So as we have all these values, putting this, we will have 5 times of 83 minus 15 times of 25 divided by 5 times of 55 minus 15 square. This gives the regression coefficient to be equal to 0.8. Now with this regression coefficient, the regression line y on x will be given as y minus y mean equal to byx times of x minus x mean. And we have all the values, so we'll put it here. Y minus 5 equal to 0.8 times of x minus 3. This becomes y minus 5 equal to 0.8x minus 2.4, which is y equal to 0.8x minus 2.4 plus 5, and therefore y becomes 0.8x plus 2.6. So this is the second line, that is y on x. So basically we have found both the regression lines, that is x on y and y on x. So x on y is x equal to 0.8 times of y minus 1, and y on x is y equal to 0.8x plus 2.6. So let us say this is equation number 1 and this is equation number 2. So the second part says that we have to estimate x when y is equal to 12. So in this case, we will use equation 1 and we will have x is equal to 0.8 times of y, which is 12, minus 1. So this will become 9.6 minus 1, and therefore x becomes 8.6. 8.6. Also, estimating y when x is equal to 8. We will have, using equation 2, y equal to 0.8 times of 8 plus 2.6. So this becomes 6.4 plus 2.6, and therefore y is equal to 9. So we have got all the results, that is the regression line of x on y, the regression line of y on x, the estimation of x when y is 12, and the estimation of y when x is equal to 8. Thank you.